Good evening. Welcome back. We are getting into lesson 14.1. This is Introduction to Polynomials. There are a lot of vocabulary words and terminologies that you have to learn in this lesson. So I suggest that you take notes as and when you're watching the video. Pause the video as and when needed and then write it down in your notes. So the first vocabulary word, polynomials itself. Poly means many. Nomials means terms. So polynomials are nothing but they are algebraic expressions, not equations. They are algebraic expressions with many terms in it. The conditions for those terms. So there are many terms. We have seen algebraic expressions so far. So you know what a term is. So what are the conditions for those terms? In an algebraic expression or in a polynomial, which has many terms, just like an algebraic expression, each term may have a coefficient and or a variable. Each term has a number and or a variable attached with it. There can be a term without any variable in it also. We will look at all those things, okay? And each term may have more than one variable. Say 3xy. So 3xy is a term which has variable x and y. Alright, so it can have more than one variable in it. Each variable in the term may have exponents attached with those variables. What kind of exponents they can have? It can only be a positive integer exponent. In other words, no negative exponents are allowed, meaning variables can't appear in the denominator of a term. If the variable is in the denominator, that means it has a negative exponent. Variables can't be in the exponent position, like in your exponential function where x is in the exponent position. The variables can't be in an exponent position. And the variables can't be in a radical symbol, like it cannot have a fractional exponent. You know that radicals can be expressed as rational exponents. So my variables cannot have rational exponents or fractional exponents like half, 3 by 2 and all that, 3 over 2 and all that stuff. So you cannot have a fractional exponent. Alright, so those are the conditions for my terms. Alright, so if we have to write an example of a polynomial, you can see that it's just an algebraic expression. It has many terms. And just like you figure out your terms in your algebraic expression, the terms are separated by the plus sign or the minus sign. So if I have to look at this polynomial, I have term number 1, I have term number 2, term number 3, term number 4, term number 5, and term number 6. So this is a polynomial that has 6 terms. Each terms are distinct from each other, meaning none of the terms have the same combination of your variables. This is an xy square, this is x square y square. So this is not the same. Xy square and x square y square is not the same. X cubed y square is not the same. X cubed, that's different from these. Y is different from this. 4 does not have any variable. This is the first rule that we saw. It may or may not have a variable. So this term does not have a variable to it. So in a polynomial, the term may or may not have a variable in it. But even if it has a variable, it can have more than one variable in a single term. So this has 2 variables. This has also 2 variables. But as you can see, the exponents are different in them. So that means this is a different set of variable. This is a different set of variable. These 2 terms are not alike. These 2 terms are not alike. So when I talk about distinct terms mean 2 things are not alike. 2 terms are not alike. Okay, so let's write that down. Distinct terms. Distinct terms means no 2 terms are alike. Meaning no 2 terms have the same combination of your variables. Okay, So this is xy square, this is x square y square, x cubed y square, x cubed y, and 4. So all these numbers are coefficients. This is a constant term, just like in your algebraic expression. This is a constant term. Non-example, an example for something that is not a polynomial. So as you look at this, this is also having 1 term, 2, 3, 4, and 5 terms in it. This has a negative exponent, so this is not part of a polynomial. This variable is in a radical symbol. It cannot be a polynomial. 3 over y square, the variable is in the denominator part, cannot be a polynomial. This is an okay. If I didn't have any of these and I just had the 7x plus 8, then it could have been a polynomial, but because even if any one of them is present, it will not be a polynomial. So polynomials are algebraic expressions with many terms. Alright, the next concept is classifying polynomials. Okay, classifying polynomials. Polynomials can be classified based on two things. One is based on the number of terms that are in the polynomial. Alright, so a polynomial can have 1 term only, or it can have 2 terms, 3 terms, 4 terms, 5 terms. Okay, so all are polynomials, but some of them have some specific names. So we're going to take a look at it. The first vocabulary word is monomial. A monomial is a polynomial that has only 1 term in it. So monomial is also a polynomial, but it has only 1 term in it. If I want to give examples, okay, if I want to give example, if I go back to our example that we wrote earlier, this is a monomial. This is a monomial. Term number 3 is a monomial by itself. Term number 4 is also a monomial by itself. Term number 5 is a monomial by itself. Term number 6, which is a constant term, could also be a monomial by itself. Alright, constant terms are also monomials. Okay, so I have 6 monomials together making a polynomial. Alright, so monomial is a polynomial that contains only 1 term. Binomial, as the name suggests, bi means 2. Binomial means it contains 2 distinct terms. We saw what distinct terms are. Distinct terms means no 2 terms are alike. No 2 terms are alike. Distinct means no 2 terms are alike. Meaning the variable part of the term, the variable part is different. Variable part is different in some way. Okay, say for example 4x square y plus 3x square y. These 2 terms, this is a polynomial, but these are alike because the variable part, if you look at it, it is x square y here, and this is also x square y. That means these 2 terms are alike. When they are like terms, I can combine them. So I have 7x square y. So this is no longer a binomial, this is a monomial. Alright, so when I talk about binomial, it has to contain 2 distinct terms, meaning no 2 terms are alike. Alright, now comes trinomial. Trinomial, as the name suggests, tri means 3. It contains 3 distinct terms, meaning 3 different terms that has different set of variables in it. Okay, different combination of your variables. All other polynomials are just called polynomials. Okay, for some reason these 3 get special treatment. So monomial, binomial, trinomial, all other polynomials that has 4 terms or more, they are just called polynomials. Alright, so that's based on classification based on the number of terms. Classification based on the number of terms in the polynomial. Next classification is based on the degree of a polynomial. What is the degree of a polynomial? We are going to learn it in a bit. but let's just look at the classification, the names that are given to those. Okay, so based on the degree of a polynomial, if the degree of a polynomial is 0, if the degree is 0, it's called a constant. If the degree is 1, it's called linear. If the degree is 2, it's called quadratic. Some of you might think quad means 4, but quadratic is degree 2. Okay, there is always this confusion that happens. We will look at why it is called quadratic in class. Okay, so degree 2 is quadratic. Degree 3 means it is cubic. All other degrees, we are just going to use the number as the 4th degree, 5th degree, 6th degree, and so on and so forth. Okay, there are names to this. If you want to Google it and figure it out, you can do that. There are names to it, but for the sake of this year, you're just being introduced to this concept. So we're going to only restrict ourselves to learning these 4 names. All right, everything else we're going to just say it is a 4th degree, 5th degree, 6th degree. If it is degree 7, we're going to call it a 7th degree polynomial. Okay, so here, based on the degree of a polynomial, these are the names given to this. Okay, so when we are classifying polynomials, we are not just going to classify based on the number of terms or the degree of a polynomial. We are going to put both of them together. The degree, based on the degree, what is the name, and based on the number of terms, what is the name. So we are going to put both of them together and write the name of the polynomial. We will do that in a bit, but let's first understand what a degree of a polynomial is. Okay, for that so let's understand what is the degree of a polynomial is. So to understand what a degree of a polynomial is, let's go back to the example that we wrote earlier. This is a polynomial that we wrote as an example. This polynomial is a collection of 6 different monomials. I have 6 different monomials in this polynomial. So in this polynomial, first I have to figure out the degree of each of the monomial. What is the degree of a monomial? The degree of a monomial is the sum of all the exponents of the variables in the monomial. Okay, so if I consider this monomial, the variables are x and y square. So x, y square is the variable part of this monomial. So it's the sum of all the exponents of the variables. So the exponent of x is 1, the exponent of y is 2. So the sum of all the exponents is 3. In this monomial, the sum of all the exponents, 2 plus 2 is 4. In this monomial, the sum of all the exponents is 5. In this monomial, sum of all exponents is 3. There is only one variable there. The exponent is 3, so I'm just writing that. Here the variable is y, the exponent is 1. There is no other variable. So the sum of all the exponents in the variable part is 1. There is no variable here, so the exponent part is 0. Alright, so this is the sum of all the exponents of the variable part in your monomial. So that's the degree of each monomial. So now the degree of the polynomial is the highest of all of these degrees of each monomial. Okay, so I have different degrees here. So out of all these, 5 is the highest one. So the degree of the polynomial is 5. So the degree of the polynomial is 5. So whichever is the highest one becomes the degree of that polynomial. So as I said earlier, when I am classifying polynomials based on the number of terms and the degree of the polynomial, I'm not just going to classify it based on one of them. I'm going to write the name based on both the degree and the number of terms. So in that case, if I look at it, if I want to write the name of the above polynomial based on the degree and the number of terms, it's a 5th degree polynomial because there are more than 3 terms. So anything that has above 3 terms, we just call them polynomial. Okay, if there were only 3 terms, I will call it a 5th degree trinomial. If there are only 2 terms, I will call it 5th degree binomial. But in this case, there are more than 3 terms, so it's a polynomial. So it's a 5th degree polynomial. We will do more examples in class. So please be familiar with all the terminologies that we learned in this video. Thank you.